Hey everybody, this is Larry. This is day 16 of the 30-day Leetcode challenge. Yeah, just gonna go jump right into it. Hit the like button, hit the subscribe button while it's loading and all that stuff, and let me know what you think. Okay, valid parentheses string. Given a string containing only three types of characters, left paren, right paren, and the star function, write a function to check whether this string is valid. We define the validity of a string by these rules. Left paren must have a corresponding right paren. Any right paren must have a corresponding left paren. Left parens must go before the corresponding right paren, and star can be treated as a single right paren or a single left paren or empty string. An empty string is also valid. But n is only up to 100. Okay, so I think there are a couple of ways that I'm thinking about this immediately. I think the big one is, well, I do have a tendency to just do dynamic programming. And given that n is 100, that's going to probably run enough. And the recurrence is kind of easy, is that given the left and the right string are the substrings equivalent. And even if you like, and yeah, and you could just, you know, you could do some math, but it's going to be n cubed at the worst. Yeah, I mean, I think it's going to be n cubed at the worst, and maybe we do that, maybe we don't, I don't know. But I think that's my initial thought, and my second thought behind that is, can I do a little bit better than n cubed, right? Given n is equal to 100, I don't think I have to. Um, and maybe that, yeah, maybe that's fine. Maybe I'm going to do that, and then, and yeah. Yeah, I think I'm going to think about it with dynamic programming because so usually let's say there are no stars. Um, if there are no stars, then uh, there's a stack solution where you kind of basically match the left and the right, and each of those parentheses has a depth. But in this case, because of the star, where it can increase the depth or lower the depth, um, I don't have a great intuitive sense as to whether this is more intelligent or more clever algorithm. Uh, my inclination is probably dynamic programming. Oh yeah, and it could also be an empty string, so that's the other thing. Um, I think actually, I empty string maybe makes it more interesting in that maybe you're forced to choose something for the star. I think for now I'm not quite proving that quite yet. So yeah, so I think I'm gonna write a dynamic programming recurrence based on this, and then we'll figure it out. Yeah. Okay. So I did say that there's gonna be a left right one, but actually I think there's so that's gonna be n cubed if we did it in some clever way. But I think actually there is an n square algorithm with dynamic programming that's actually, well, I mean, n squared is obviously better than n cubed with a different recurrence by noticing that, yeah, on the left, because let's say at most, the depth is going to be O of n in terms of like the number of parens that you have open or whatever. Um, and because of that, the recurrent states or your state's dimension could be the depth plus how many from the left. So you can always just do it from left to right versus some almost like a uh, recursive descent type thing where you parse the parentheses in a clever way. So in that case, that'll be n squared because at every index, you only have three choices. Well, if it's a left paren or right paren, you have no choices. But given a star, then you have three choices, right? Left paren, right paren, or an empty string. So let's kind of go that. Let's start. Yeah, let's start by playing with that, and then we'll kind of see how it goes. Okay, let's go. So yeah, so I so a little bit thing is that I'm a little bit lazy today, in the sense that I'm going to use something that native to Python called the Lru Cache, which is in functools. And basically, what it does is it takes a function and then it memorizes, you know, um, depending on the incoming parameters and the outgoing, the next time you call the same thing, it will, based on off an Lru cache, either return a result or recalculate it. And if you set the age, or you keep all the items, then you're going to keep all the items. But one thing that I would advocate, and I'm only doing this because I'm an expert, quote unquote. But definitely make sure that you measure your state in a way so that like for an interview especially, make sure you really understand what you're writing, because, well, look, Leetcode running the test and submission, they'll test whether your code is correct, but it's not gonna show that you can prove the Leetcode that you actually understand the problem, right? And that's something that I would maybe practice a little bit and make sure that you understand. I mean, I know I understand, I think so, but yeah. So let's just say is valid. Let's have two dimensions for now, index and the depth, right? As we said, let's set n is equal to length of s. And then now what are the base cases, right? If index is equal to n, that means we're at the end of the string. Then if depth is equal to 0, we're good, so we turn true. Else, we turn false, because that means we are, that means we have open strings left, right? So let's return false. Another kind of early termination case is that if depth is less than 0, then we turn false. I mean, that makes sense. That means you have more right parens than left parens, so this is not going to be a valid string. You can also put this in the caller, so I can show you in a little bit. But sometimes I don't know. I mix it up. It's not deterministic, probably not. But yeah. So now let's check what the s of index is then. So if this s of index is equal to left, autocomplete, then then that means return is valid index plus 1, depth plus 1, right? So hope that makes sense. Leave a comment if you have any questions, by the way. And conversely, if it closes, then okay, let's go. It's valid index plus 1, depth minus 1. And yeah, and if this seems easy to you and you've already done this, do it. Maybe try to practice bottoms up, and try to figure out how to do that, and that would be interesting. And you could even make the space complexity way better, actually, in that case. So yeah. Anyway, okay. So if it's a star, that means it's a star. So I'll wait a comment. As in x is equal to a star. Then we try any of the three possibilities, right? Which is return is valid index plus 1, depth plus 1, or is valid index plus 1, depth, or is valid index plus 1, depth minus 1. I guess you could actually write this in a for loop. But it's okay. This is easy enough to understand why. But yeah, and then that's pretty much it. And then now we just have to call the is valid 0. You start with the 0 index, and the depth is also 0 because you start at the 0 depth. And then that's one the code and also one other code. Just typing it in though. Okay, maybe not. Let's do this. Let's run it real quick, but we also should have more test cases, obviously. Empty string left, and also just a case where false would be nice, because it seems like just a bunch of stuff. And and normally obviously you would double check your answers, but at least for now, Leetcode tells you the expected answer. So it looks like everything match. Am I confident? I feel like I'm pretty confident. So I'm gonna submit. Cool, accepted. Yeah. So one common thing is to think about is what is the running time, the complexity, and for dynamic programming, it's not as straightforward as counting the for loops. So if you wrote it with bottoms up, then you could see the for loops and it's more obvious. But yeah, I could actually see this as an interview question. It's not hard. Actually, I think it's actually interesting because it definitely takes something that most people have practiced on, which is, like calculating a valid parent string, and then added a little bit more complexity with the star, which I actually haven't. I don't know if this is a new problem, but that's kind of cool. I don't remember seeing this problem anyway. And the recurrence is kind of simple to write. Maybe if you finish as fast as I just showed you on stream, maybe maybe rewrite it as bottoms up just to practice. And also, if you're interviewing, make sure you understand why. Like I mostly for laziness I would Lru cache, but definitely make sure you understand the states and analyzing the complexity. Well, how many indexes are there? Well, for the string, that's just going to be n index. Depth, how many depths are there? Well, there's going to be at most n depth, especially since you can't even go negative. So the depth will be at worst be length n or n over 2. You want to be like, so there's another short, like you could short circuit this by doing something like, if n minus index is greater than depth or something like that, return false. Maybe there's an off by 1, so you have to double check. But the idea there is like, okay, well, if we don't have like five characters left and your depth is like 7, that means there's no way for you to close that gap, right? So that's kind of the thing, but it's not even necessary, right? That's only a constant time optimization. So there's n index, n depth, so the algorithm is going to be, or there's going to be n square possible states, and each state we do all of one work, right? So for these two cases it's obvious, but this is also all of one. It's just three operations or series of operations. So yeah, so definitely an interesting thing, and it points out that there's an overran solution, which I'll maybe think about in a little bit. But yeah, for competitive programming, this is actually a reasonable one. Maybe a very easy hard or a very on Leetcode scale, maybe a very easy hard or a hard medium or something like that, or harder medium. Um, but for interview, I think this is actually an interesting problem, especially since I think there are a couple of ways to solve this. I think you can even, like I said, like you could do even dynamic programming. You could probably do a naive one that's an n cube. There may be other ways that you can, like there may be divide and conquer methods to solve this as well, but that's kind of also related to a naive way of doing it. Um, but so there have a lot of different possibilities, so that even if, because what I look for as an interviewer when I see a problem is that even if the candidate is not able to solve the problem perfectly, I want to kind of see the thought process and then maybe nudge them a little bit in the right direction, or just to see how they take hints and then kind of see where they go with it and problem solving. Sometimes you're a little bit stuck on a little thing, and then you get a little bit nudge and it opens a floodgate. Sometimes you just get stuck forever. Those are a little bit sad. And in this problem, I feel like you can give hints because one hint is not going to solve the problem with someone. It's just nudge them in the right direction. So I actually do dig this problem, and definitely fundamentally study a little bit about the you know there are not prerequisites, but problems that are similar to this problem but a little bit easier. Like if there's no star, I guess that's the Kananaga one, and then there's, which is also interesting, at least for a beginner. So I definitely dig this problem, and I feel like it's been a little bit of a time since, or at least this is at least possibly for now, maybe my favorite. Actually, I like Tinker's Array a little bit. So yeah, but yeah. Also, just want to add, yeah. So the way that I did was dynamic programming. The benefit of dynamic programming is that you don't have to prove it correct. I think there's apparently there may be a linear time solution where you have to do some math, but usually it's because it's greedy, and then you have to prove it correct. I think there's some. So looking at the, so I think looking briefly at the solution. So I am cheating a little bit. Oh, actually, I mean, I did this in. So this is an n squared dynamic programming. So we did it slightly better, because we don't do this for loop. But I did not think about a greedy one. I think greedy problem, to be honest, is one of my weak points. Mostly because they're usually ad hoc, and at least for me, you have to do work to prove it correct. And for longer algorithm, longer contests, I will probably do that math. But for this problem, I did not because, well, because I just did it in a few minutes. But that's interesting. Yeah, I mean, I think the thing that I was thinking about is that there is some forcing function because of the star. You can only increase or decrease the depth, but that's the low and the high actually makes sense in terms of um, keeping track. Because if the low, that's actually a really clever algorithm. I actually like this problem a lot. I think I have to think a lot. I mean, I briefly scanned the greedy, but I didn't really like looking that deeply into it, and that's by design because I really want to now. Now that I know that there's a possibility of a greedy overfan algorithm, I'm going to spend some time offline to kind of, well, one, come up with it, and then two, prove to myself that it is correct. So, kind of always gotta keep on learning and figuring out how to learn. So that's important. And I probably got too much of a hint already with the low high, but yeah, but that's what I'm gonna do. Cool, good problem. And what else is there? I think that's it. So I will see the stream tomorrow. Thanks for watching and all that stuff. Hit the like, subscribe button and all that stuff. Thank you.